In this video, I'm going to break down some essential Python concepts step by step in a way that's easy to understand. By the end of this, you'll have a solid grasp of the basics. All right, let's dive into the first topic. What exactly is Python programming? Python is what we call a high-level programming language. But wait, what does high-level even mean? Basically, it's designed to be close to human language. Imagine telling a computer, hey, just do this for me, and it actually understands you. That's the simplicity Python brings. So why is Python so popular? It's because it's ridiculously versatile. You can use it to build websites, analyze data, automate boring tasks, create games, and even develop AI models. Here's what I love about Python. It's beginner-friendly. You don't need to know a lot to get started. It's clean and readable. The code almost looks like plain English. It's super powerful. Even professionals use it for some of the most advanced tech out there. So now that you've got a basic idea of what Python is, let's move on to the very first topic of this beginner-friendly Python bootcamp, the print function. The print function is probably the most used function in Python, especially for beginners. It's like your way of talking to the computer, saying, hey, display this on the screen. It's simple, yet super powerful. Here's how it works. We first need to type print and then add parentheses. And now we put whatever we want to display inside these parentheses. And Python does the rest. So let's write our very first Python code. Hello world. And now, as we run the program, you can see that hello world is displayed as the output on the screen. It's that simple. You can put text, numbers, or even a combination of both inside print. Now, let's break this down a little. In the example above, hello world is what we call a string. Basically, it's a piece of text. In Python, you need to wrap strings in either double quotes or single quotes. Both work the same way. For example, if we write two print statements, one with single quotes and one with double quotes, on running the program, both of these will work perfectly fine. But make sure to be consistent. Don't mix and match single and double quotes in the same string, or Python will get confused. For example, if you start your print statement with single quotes and end with double quotes, then on running the program, you get the syntax error that says unterminated string literal. This error message simply means that we didn't close our print statement correctly. Now, let's say you want to print numbers instead of text. Well, that's easy. You don't need any quotes for numbers. You simply write the number that you want to display as the output, and on running the program, Python will display the number. But what if you want to combine text and numbers? Let's say you want to display something like the answer is 42. Here's one way to do it. We write print followed by parentheses, and then inside the double quotes, we enter our text, and then we enter a comma and the integer 42. So now, as we run the program, we get the text and the number as the output. See what I did there? You can separate text and numbers with a comma inside print, and Python will handle it for you. Pretty neat, right? All right, now that you're comfortable with the print function, let's move on to something even more exciting, variables. So what are variables? Think of a variable as a container. Imagine you're writing down something important on a sticky note and giving it a name so you can find it later. That's exactly what a variable does in Python. It stores data so you can use it whenever you need. So the syntax for creating a variable looks something like this. We first write the variable name, then we use the equal sign, which is known as the assignment operator, and then we write whatever value we want to store in our variable. For example, let's write the name equal to Mike. In this example, we're storing the text Mike in a variable called name. Now, every time we use the name in our code, Python will know we mean Mike. So now, if we print the name, then on running the program, Python will display Mike as output. Before we go further, let me tell you a few simple rules for naming variables. The first rule we have is that variables cannot contain special symbols other than the underscore. Python allows the use of underscores for defining the names of variables. So if we try to add any other symbols to our variable, then we get the syntax error in our program. Now, the next rule we have is that variables in Python cannot start with numbers or any other symbol. So for example, if we create a variable that starts with either an underscore or a letter, then our program runs perfectly fine. But now, if we try to start our variable with a number or with some symbol, in that case, Python will again throw a syntax error. Now, the next rule we have is that variables in Python are case sensitive, which means if we create two variables called name, but in the first variable the letter N is capitalized and in the other it's written in small letters, then both of these variables are different. Now, the last rule we have is more like a good practice in programming. Instead of giving some random names to variables like x or y, you should give meaningful names to your variables so that in the future, when you come back to your code again, you can understand what your code means. Now, Python is a dynamically typed programming language. That means we don't have to specify the type of data that we use. Python does that for us. So if we assign a text value to a variable, then Python will treat it as the string data type. So for example, if we create a variable called x and assign a text to it, and then we use the type function to check the data type that variable x stores, then on running the program, we get the output as class string, which means Python tells us that this piece of data belongs to the string data type. And now, instead of text, if we assign a number to the variable x and again run the program, this time we get the output as int, which means this belongs to the integer data type. Now, the best part about variables, you can change their value anytime. You can change the values of variables at any time in your program. For example, if we create a variable called score and assign the value 50 to it, and now if we print the score, then we get 50 as output. But now if I change the value of score to 100, then on running the program again, this time we get 100 as output, and not our previous value of 50. See how easy it is to update a variable? Python doesn't lock you into using the same value forever. Alright, now that you're familiar with variables, let's move on to the next topic in our Python bootcamp, data types. Think of data types as the kind of information your variables can hold. Every piece of data in Python belongs to a specific type, and knowing these types is super important to write efficient and error-free code. Let's go through the key data types in Python one by one. First, we have the string data type. str, or string, is used to store text. It can be a single character, a word, or even a full sentence. Strings are always enclosed in quotes, either single or double. So for example, let's create a first name variable and the last name variable. In the first name, we use double quotes to assign the value. And in the last name, we use single quotes to assign the value. So now, if we check their data type using the type function, then both of these values belong to the string data type. We can also use the len function to check the total length of the strings. So if we use the len function and pass hello world, then on running the program, we get the output as the total length of our string value. One point that you need to keep in mind is that when you use the len function, it also counts the white space and not just a sequence of letters. Now, the second data type we have is the integer data type. An integer data type in Python is used to store whole numbers. No decimals, no fractions, just plain simple whole numbers. It can be positive, negative, or even 0. So if we create 3 variables, and in one we assign 100, in another we assign some negative value, and in the last we assign 0 as the value, now if we check their data type using the type function, then all of these values belong to the integer data type. You'll use integers all the time in Python for things like counting items, performing math calculations, working with loops, or indexing. Integers are super efficient and are one of the most commonly used data types in any program. Now that we've covered integers, let's move on to the next important data type, float. If integers are for whole numbers, floats are what you use when you need more precision, like working with prices, measurements, or anything involving decimals. A float in Python represents any number with a decimal point. Think of it as a way to handle fractions or more precise values. Here are a few examples. In these examples, price is a float for currency. Pi is a float representing the mathematical constant, and temperature is a negative float. All of these values belong to the float data type. So why use the float data type? Floats are incredibly useful for handling calculations that need precision, like financial or scientific data, storing fractions of a number like percentages or probabilities, and working with measurements, example weight, height, distance. Floats can get really long sometimes with lots of decimal places. If you don't need that much precision, you can use the round function. For example, let's say we have a very long value of pi, but we only want its decimal value up to 2 digits. So in this case, we use the round function, and inside it, we pass the pi and the number of digits up to which we want our decimal point. So now, if we run the program, then we get the decimal value up to 2 digits only. Alright, now that we've explored numbers with integers and floats, let's shift gears and talk about something more logical, the Boolean data type. A Boolean, or bool, is a data type that can have only 2 values, true or false. That's it. Think of it as a simple light switch. Either it's on, which is true, or off, which is false. Booleans are the foundation of logic in programming. They are used in decision-making, conditions, loops, and even math at times. The value of true is equivalent to 1, and the value of false is equivalent to 0. So, for example, let's create a variable called x and assign the value true to it. And now, if we print the x and check the type of x, then on running the program, we get the output as true, and the class it belongs to is bool. Alright, now let's move on to one of the most versatile and commonly used data types in Python, the list data type. If you've ever written down a shopping list, a to-do list, or even just a list of your favorite movies, then you already understand the basic idea behind Python's list data type. A list is an ordered collection of items. The purpose of the list data type is to store multiple items of the same or different data types. It's like a container where you can store multiple pieces of data, like numbers, strings, or even other lists. The cool thing about lists is that they belong to the mutable data type, which means we can modify the content of our list after its creation. The syntax of lists looks something like this. Here we have open and close square brackets, and inside the brackets we enter our items, and each item is separated by a comma. So for example, let's create a list called myList. This list contains items of different data types, and each item is separated by the comma. So now if we print myList and run the program, then you can see that the same list is output. And now if we check its type, then you can see it belongs to the list data type. Now, before going deep into the list data type, we first need to understand the concept of indexing and slicing operations in Python. These are like tools that let you zoom in on specific parts of your data and work with them efficiently. So what does indexing mean? Indexing is the process of accessing the individual items from a sequence, like a list, string, or tuple. In most of the programming languages, especially in Python, the indexing starts from 0, which means the first item in our list, or the first character in our string, is at index 0. And then the next item is at index 1, and so on. So to access the specific item from a sequence, we have to enter its index number within the square brackets. So in this example, to access the letter T from the string, we have to enter its index number, which is 2 in this case. And to access the letter O, we have to enter its index value, which in this case is 4. And now, what does slicing mean in Python? While indexing gives you one item at a time, slicing lets you grab a whole section of the sequence. It's like cutting out a piece of the list. So now if we look at the syntax of slicing, then it looks something like this. Here we first have the start index number, then the end index number, and then we have an optional step value. Start is the index where the slice begins, stop is the index where the slice ends, and the step is the number of items it needs to skip. So, for example, let's say we have a list of letters, and now we want to extract the letters from C to F. So for that, we have to pass the starting index as 2, and the ending index will be the index of F plus 1, which means the index number of F, that is 5 plus 1. So the ending index will become 6. So now if we run the program, then we get the sequence of letters from C to F. And now let's say we want to extract the letters by escaping one letter every time. That means we first extract A, then we skip the B, and then we extract C, and again skip the D. So we will enter the starting index as 0, and the ending index is 27, and the step value is 2. So now as we run the program, we get the desired sequence of letters as the output. So now let's get back to the list data type. In the list data type, we have several predefined functions that we can perform with the list data type. So let's discuss some of the predefined functions. First, we have the append function. This function is used to add an item to the end of the list. So to do this, we will use the append function and then add the item that we want to add in the list. So now as we run the program, then you can see that the item has been inserted at the end of the list. But now, let's say we want to add an item at a specific place in the list. So for this, we can use the insert function. In this, we have to pass two arguments. First is the index value where we want to insert the item, and then the item itself. So now if we enter the index value of 2 and the item that we want to insert, then on running the program, you can see that the item has been inserted at index 2. And to remove the item from the list, we can use the remove function. In this, we have to pass the item that we want to remove from this list as an argument. So if we use the remove function and enter mango as the argument, then you can see that mango has been removed from the list. And you can also use the pop function to remove the item from the list. For this, we have to enter the index value of the item. So now if we pass the index value of 0, then on running the program, the item present at index 0 has been removed from the list. We can also use the len function to check the total number of items in the list. This function will give the total number of items that our list currently has. And now if we want to find the index of the first occurrence of a specific item in the list, then we can use the index function. In this, we have to pass the item whose index we want to find. So if we use the index function and pass mango as the argument, then on running the program, we get the index value of mango. We can also sort the items of the list by using the sort function. For example, if we use the sort function and run the program, then we get the sorted list as the output. And the sorting is done in ascending order. And now if you want to sort the list in descending order, then you just have to set the value of reverse to true in the sort function. So now if we again run the program, then we get the same list as output, but in the reverse order. And let's say now we want to remove all the items from the list. So for this, we can use the clear function with our list. So now if we run the program, then we get the empty list as output. So these are some of the most commonly used predefined functions that are available with the list data type. All right, we've spent some time with lists, but now it's time to introduce their closely related sibling, the tuple data type. So what is a tuple data type? A tuple is an ordered collection of items, just like a list. However, there's one big difference. Tuples are immutable. Once you create a tuple, you can't change its content. Think of it as a locked box where you can't add, remove, or modify items. The syntax for creating a tuple data type is almost the same as the list data type, but with one major difference. Instead of the square brackets, we use the parentheses to create a tuple. So for example, let's create a variable called myTuple. Then we will use the parentheses to create a tuple, and then we will add different items separated by the comma. So why would you use a tuple if you can't change it? Here are a few reasons. So the first reason we have is data integrity. If you have data that shouldn't be modified, like coordinates or configuration settings, tuples are perfect. Next, it has faster performance. Tuples are generally faster than lists because they're immutable. And also, we can use the tuple as keys in dictionaries. Since tuples are immutable, they can be used as dictionary keys. But there is something very interesting about the tuple. So let's say we want to create a tuple that only has a single value. So now if we check its type and run the program, then why it's showing the string data type as output and not the tuple? So why we are getting a string as output and not the tuple? When we create a tuple with a single item, we have to include a trailing comma. Without it, Python will think it's just a regular value. So now if we had a comma with the element and again run the program, then this time we're getting class tuple as the output. And on the tuple data type, we can perform both the indexing and slicing operations. So we can access any special items from the tuple by using its index value. So if we try to access the item at index 3 and run the program, then we get the item of index 3 from the tuple. And also, if we specify the starting and ending index, then we get the sequence of items as the output. And since it belongs to an immutable type, so we cannot modify it. And if we try to modify the tuple, then we get the type error as output. And the error message says that tuple object does not support item assignment. All right, now that we've covered tuples, let's talk about another incredibly useful data type in Python, the set. If you've ever worked with data and wanted to ensure there are no duplicates or perform mathematical operations like union or intersection, sets are your best friend. So what is a set data type? A set is an unordered collection of unique items. Think of it like a bag of items where duplicates are automatically removed and the order doesn't matter. The syntax for creating a set data type looks something like this. We use the curly brackets, and inside the brackets we enter different items names separated by the comma. So for example, let's create a set called nums that contains some integer values in it, and we also have some duplicate items in it. So now if we run the program, we get the set as the output, and also the duplicate items have been removed, and it only contains the unique items in it. So now that we understand what a set is, let's talk about the predefined functions that we can perform on the set data type. Just like lists, Python provides us with several built-in functions to work with sets easily. First, we have the add function. This function is used to add a single element to the set. So to use this, we write our set name, then dot, add, and inside the parentheses, we pass the value that we want to add. So now when we run the program, you can see that the new value has been added to our set. And even if we try to add a value that already exists in the set, Python will simply ignore it because sets only store unique values. Now, let's say we want to add multiple items at once into the set. For that, we use the update function. In this function, we pass another set or a list containing multiple values. So now, when we run the program, you can see that all the new values have been added to our set. Next, let's talk about removing elements from a set. To remove a specific element from a set, we can use the remove function. In this function, we pass the value that we want to remove from the set. So now, when we run the program, you can see that the value has been removed successfully. But here is one important thing you need to remember. If you try to remove a value that does not exist in the set using the remove function, Python will throw an error. To handle this safely, Python gives us another function called discard. This function also removes an element from the set, but if the element does not exist, Python will not give any error. It will simply skip the operation. So this makes discard a safer option in many cases. Now, we also have the pop function. This function is used to remove a random element from the set. Since sets are unordered, Python removes any one element randomly. So when we run the program, one element is removed, but we don't know in advance which one it will be. Next, we can use the len function to check the total number of elements present in the set. This function returns the count of unique elements that the set currently contains. So when we run the program, we get the total number of items as the output. Now, let's move on to one of the most powerful features of sets, set operations. First, we have the union function. This function is used to combine elements from two sets. It returns a new set that contains all unique elements from both sets. So when we run the program, the output includes all values from both sets without any duplicates. Next, we have the intersection function. This function returns only the elements that are common between both sets. So when we run the program, we get only the values that exist in both sets. After that, we have the difference function. This function returns the elements that are present in the first set, but not in the second set. So when we run the program, we get only those values that are unique to the first set. And finally, we have the symmetric difference function. This function returns elements that are present in either of the sets, but not in both. In simple words, it removes the common elements and keeps the rest. So these are some of the most commonly used predefined functions that are available with the set data type. All right, now let's move on to one of the most powerful and widely used data types in Python, the dictionary data type. So what is a dictionary in Python? A dictionary is a collection of data that is stored in the form of key-value pairs. Think of it like a real-life dictionary, where each word is a key and its meaning is the value. In Python, we use dictionaries when we want to store data in a meaningful way, where each value is associated with a unique key. The syntax for creating a dictionary looks something like this. We use curly brackets, and inside the brackets, we write the key, followed by a colon, and then the value. Each key-value pair is separated by a comma. So, for example, let's create a dictionary called student. In this dictionary, we store the name, age, and marks of a student. Now, if we print the dictionary and run the program, then you can see all the key-value pairs displayed as the output. And if we check its type using the type function, then you can see that it belongs to the dict data type. Now, one important thing to understand about dictionaries is that keys must be unique. If we try to use the same key again, Python will overwrite the previous value with the new one. Also, dictionary values can be of any data type: string, integer, list, tuple, or even another dictionary. Now, let's talk about accessing values from a dictionary. To access a value, we simply write the dictionary name, and inside square brackets, we pass the key. So now, when we run the program, we get the value associated with that key as the output. Now, let's move on to the predefined functions that we can perform with the dictionary data type. First, we have the get function. This function is used to access the value of a key safely. Inside the get function, we pass the key whose value we want. So when we run the program, we get the value of that key. And the advantage of using get is that if the key does not exist, Python does not throw an error. Instead, it returns none. Next, we have the keys function. This function returns all the keys present in the dictionary. So when we run the program, we get all the keys as the output. Then we have the values function. This function returns all the values present in the dictionary. So when we run the program, we get all the values stored in the dictionary. After that, we have the items function. This function returns both keys and values together in the form of pairs. So when we run the program, we get all the key value pairs as the output. Now, let's talk about adding and updating values in a dictionary. To add a new key-value pair, we simply write the dictionary name, then inside square brackets, we write the new key and then assign a value to it using the equal sign. So now when we run the program, you can see that the new key-value pair has been added to the dictionary. And if the key already exists, then Python will simply update its value. So dictionaries allow both adding new data and updating existing data very easily. Now let's talk about removing elements from a dictionary. To remove a specific key-value pair, we can use the pop function. Inside this function, we pass the key that we want to remove. So when we run the program, that key-value pair gets removed from the dictionary. We also have the pop item function. This function removes the last inserted key-value pair from the dictionary. So when we run the program, the last item is removed. And if we want to remove all the elements from the dictionary, we can use the clear function. So now when we run the program, we get an empty dictionary as the output. We can also use the len function to check the total number of key-value pairs present in the dictionary. This function returns the size of the dictionary. So these are some of the most commonly used predefined functions that are available with a dictionary data type. All right, now that we've covered the major data types in Python, let's talk about typecasting. So what exactly is typecasting? Typecasting simply means converting one data type into another. In Python, this is something you'll do very often, especially when you're working with user input or performing calculations. There are two types of typecasting in Python: implicit typecasting and explicit typecasting. Let's understand both of them one by one. First, we have implicit typecasting. Implicit typecasting means that Python automatically converts one data type into another without us telling it to. Python does this when it knows that the conversion is safe and there will be no loss of data. So for example, let's create one variable with an integer value and another variable with a float value. Now, if we add these two variables and store the result in a new variable and then print it and check its type, you'll notice something interesting. When we run the program, the result is a float, not an integer. This is Python automatically converting the integer into a float before performing the operation. That's implicit typecasting. Python is handling the conversion for us in the background. Now let's move on to explicit typecasting. Explicit typecasting means that we manually convert one data type into another. Python provides us with built-in functions for this. First, we have the int function. This function is used to convert a value into an integer. So for example, let's say we have a float value like 10.8. Now, if we use the int function and pass this value inside it and then run the program, you'll see that the decimal part is removed and we get 10 as the output. Next, we have the float function. This function converts a value into a float. So if we pass an integer value inside the float function and run the program, we get the same number but with a decimal point. Now let's talk about converting values into strings. For this, we use the str function. This function converts any data type into a string. So if we convert a number into a string and then check its type, you'll see that it now belongs to the string data type. This is very useful when you want to combine text and numbers together in print statements. Now let's talk about converting strings into numbers. If we have a string that contains a number like 100, then we can convert it into an integer using the int function. So when we run the program, we get 100 as an integer. But here's something important you need to remember. If the string contains non-numeric characters and we try to convert it into a number, Python will throw a value error, because Python cannot convert text into a number. So always make sure that the string contains a valid numeric value before converting it. Now let's look at one very common real-world example. When we take input from the user using the input function, Python always treats the input as a string. So even if the user enters a number, Python will still consider it a string. That's why when we want to perform mathematical operations on user input, we first need to convert it into an integer or a float using typecasting. So this is where explicit typecasting becomes extremely important. All right, before we jump into conditional statements, there is one very important topic that we need to understand first, and that is operators in Python. So what are operators? Operators are symbols that are used to perform operations on values or variables. In simple words, operators help us perform calculations, make comparisons, and apply logic in our programs. Python provides us with different types of operators, so let's go through them one by one. First, we have arithmetic operators. These operators are used to perform mathematical calculations. Let's start with the addition operator. Suppose we have two numbers, 10 and 5. If we add them using the plus operator and print the result, then when we run the program, we get 15 as the output. This is simply adding two values together. Next, we have the subtraction operator. So if we subtract 5 from 10 and print the result, then on running the program, we get 5 as the output. This operator subtracts one value from another. Now let's move to the multiplication operator. If we multiply 10 and 5 and print the result, then when we run the program, we get 50 as the output. This operator multiplies two values. Next, we have the division operator. So if we divide 10 by 5 and print the result, then on running the program, we get 2.0 as the output. Notice that even though both values are integers, the result is a float. This is because the division operator always returns a float value. Now let's talk about the floor division operator. If we divide 10 by 3 using the floor division operator and print the result, then on running the program, we get 3 as the output. The decimal part is removed and only the whole number part is returned. Next, we have the modulus operator. This operator returns the remainder of a division. So if we divide 10 by 3 using the modulus operator and print the result, then on running the program, we get 1 as the output, which is the remainder. And finally, we have the exponent operator. If we raise 2 to the power of 3 and print the result, then when we run the program, we get 8 as the output. Now let's move on to assignment operators. The most basic assignment operator is equal. For example, if we write x equal 10, then we are assigning the value 10 to the variable x. Now let's look at compound assignment operators. Suppose x is 10. If we write x plus equal to 5, this means x is equal to x plus 5. So when we run the program and print x, we get 15 as the output. Similarly, if we write x minus equal to 3, then x becomes 12. If we write x multiply equal to 2, then x becomes 24. If we write x divided equal to 4, then x becomes 6.0. So these operators help us update variable values in a shorter and cleaner way. Now let's talk about comparison operators. These operators compare two values and always return either true or false. Let's say we have two numbers, 10 and 5. If we check 10 equal to 5 and print the result, then on running the program we get false because both values are not equal. If we check 10 is not equal to 5, then the output is true because the values are different. If we check 10 is greater than 5, then the output is true. If we check 10 is less than 5, then the output is false. Similarly, if we check 10 greater than or equal to 10, the output is true. And if we check 5 less than or equal to 3, the output is false. These operators are extremely important because they are used directly in conditions. Now let's move on to logical operators. Let's say we have two conditions, x is greater than 5 and x is less than 20. Then, since both conditions are true, then the final result is true. Now, if we use the OR operator and make one of the conditions false, then even if one of the conditions is true, the final result will be true. And if we use the NOT operator, it simply reverses the result. So if a condition is true, NOT will make it false. Logical operators help us combine multiple conditions together. Now let's talk about membership operators. Suppose we have a list of fruits. If we check whether apple is present in the list using the in keyword, then on running the program, the output will be true. If we check whether banana is not present in the list using not in, then the output will be true, since we don't have the banana in the list. These operators are very useful when working with lists, strings, and tuples. Finally, we have identity operators. Suppose we create two variables and assign the same value to both of them. And now if we use the is operator, Python checks whether both variables point to the same object in memory. So when we run the program, the output will be true. If we use is not, Python checks whether they refer to different objects. Identity operators are mostly used in advanced scenarios, but it's good to know how they work. So now that we've covered operators with proper examples, understanding conditional statements will become much easier. All right, now let's move on to conditional statements in Python. So what are conditional statements? Till now, whatever code we've written, it runs line by line. Python doesn't make any decisions on its own. It just follows instructions exactly as we write them. But in real life, things don't always work in a straight line. For example, think about this situation. If you score more than 50 marks, you pass the exam. If you score less than 50 marks, you fail the exam. Now, notice something important here. The action depends on a condition. The computer needs to check something first, and based on that check, it needs to decide what to do next. This is where conditional statements come into the picture. Conditional statements allow our program to check a condition, make a decision, and execute different code based on that decision. Without conditional statements, every program would behave the same way every time, no matter what the input is. And this is why conditional statements are one of the most important concepts in programming. Now that we understand why conditional statements are needed, let's write our very first conditional statement in Python. The most basic conditional statement in Python is the if statement. So what does an if statement do? An if statement checks a condition. If that condition is true, Python executes the code inside the if block. If that condition is false, Python simply skips that block. Nothing more, nothing less. Let's look at the structure of an if statement. First, we write the keyword if. After that, we write a condition. At the end of the condition, we put a colon. Below that line, we write the code that should run only if the condition is true. And this code must be indented. So in Python, indentation is not just for readability, it actually tells Python which code belongs to the if block. So let's create a variable called age and assign it the value 20. Now we write an if condition that checks whether age is greater than or equal to 18. So what is Python doing here? Python first looks at the condition. Is 20 greater than or equal to 18? This condition evaluates to true. Because the condition is true, Python goes inside the if block and executes the print statement. So when we run the program, we see the output on the screen. Now let's change the value of age to 15. Everything else remains the same. Now Python again checks the condition. Is 15 greater than or equal to 18? This time the condition becomes false. So what happens? Python does not go inside the if block. It simply skips it and moves to the next line of code. That's it. No error, no message. This is very important to understand. An if statement does nothing when the condition is false, unless we tell it what to do. Every condition inside an if statement must result in either true or false. For example, 10 is greater than 5, which evaluates to true. 10 is less than 5, which evaluates to false. 10 is equal to 10, which again evaluates to true. Python checks the condition, gets either true or false, and then decides whether to execute the block or not. So if is always working with Boolean values in the background. Now let's talk about something extremely important, indentation. In Python, the code inside the if block must be indented using spaces. If we remove the indentation and run the program, Python will throw an error. This is because Python uses indentation to understand where the if block starts, where it ends. So always make sure your indentation is correct. So when the condition is true, the code inside the if block runs. But what happens when the condition is false? Right now, the program simply skips the if block and does nothing. This is where the else statement comes in. The else statement is used to define a block of code that runs only when the if condition is false. So you can think of it like this. If runs when the condition is true, else runs when the condition is false. There is no condition written with else. It automatically handles the opposite case of if. Let's understand the structure first. We start with the if statement and its condition. After the if block ends, we write the keyword else, followed by a colon. Inside the else block, we write the code that should run when the condition is false. Just like if, the code inside the else must also be properly indented. Let's create a variable called age and assign it the value 16. Now we write an if condition that checks whether age is greater than or equal to 18. If the condition is true, we print you are eligible to vote. And in the else block, we print you are not eligible to vote. Now let's see what happens when we run the program. Python first checks the condition. Is 16 greater than or equal to 18? No, the condition is false. So Python skips the if block and directly executes the else block. That's why we see the message from the else statement printed on the screen. Now let's change the value of age to 20. We run the program again. Python checks the condition. Is 20 greater than or equal to 18? Yes, the condition is true, so Python executes the if block and completely ignores the else block. Only one block runs, either if or else, never both. An else statement must always come after an if statement. You cannot use else by itself. An if statement can have only one else. This keeps the logic clean and predictable. So till now we've seen two things. If handles the true case, else handles the false case. But what if there are more than two possible situations? In real life, decisions are rarely just yes or no. For example, if the marks are above 90, then grade A. If the marks are above 75, then grade B. If the marks are above 50, then grade C. Otherwise, fail. This is where the elif statement comes in. Elif is short for else if. It allows us to check multiple conditions one by one. Python checks each condition from top to bottom. As soon as it finds a condition that is true, it executes that block and skips the rest. The structure looks like this. We start with if and its condition, then we can have one or more elif blocks, and finally we can have an optional else block. Remember, only one block will execute. Let's take a very simple example. We create a variable called marks and assign it a value. Now we write the conditions. If marks are greater than or equal to 90, print grade A. Elif marks are greater than or equal to 75, print grade B. Elif marks are greater than or equal to 50, print grade C. Otherwise, fail. Now let's understand how Python executes this. Suppose the value of marks is 82. Python first checks the if condition. Is 82 greater than or equal to 90? No, this condition is false, so Python moves to the next condition, which is the first elif. Is 82 greater than or equal to 75? Yes, this condition is true, so Python executes that elif block, prints grade B, and then stops checking further conditions. The remaining elif and else blocks are skipped. Now this is very important. The order in which you write conditions in elif matters a lot. If we change the order and put the condition marks greater than or equal to 50 at the top, then that condition will become true first, and Python will never reach the higher grades. So always write conditions from most specific to least specific. If none of the if or elif conditions are true, then Python executes the else block. So the else block acts like a default case. All right, now let's move to a very important concept in programming, and that is loops. Before we write any loop, let's first understand why loops even exist. Till now, whenever we wanted to print something multiple times, we had to write the same print statement again and again. For example, if we want to print hello 5 times, we would have to write the print statement 5 separate times. Now imagine if you had to print something 100 times, or maybe process thousands of values. Writing the same code again and again is boring, error-prone, and inefficient. This is exactly where loops come into the picture. A loop allows us to repeat a block of code multiple times without writing it again and again. So instead of saying, do this, do this, do this, we tell Python, repeat this task until a certain condition is met. Think about brushing your teeth. You don't think, I will move the brush left, now again left, now again left. Instead, you think, I will brush for 2 minutes. That's a loop. The action repeats until the condition of 2 minutes is satisfied. In programming, loops work the same way. We tell Python what to repeat, when to stop. Python keeps repeating the code until the stopping condition becomes false. Python mainly provides us with 2 types of loops, while loop and for loop. We'll start with the while loop because it's easier to understand logically and closely matches human thinking. So what is a while loop? A while loop keeps running as long as a condition is true. The moment the condition becomes false, the loop stops. The structure of a while loop looks very similar to an if statement. We start with the keyword while, then we write a condition, and at the end of the condition we add a colon. Inside the block we write the code that should run when the condition is true. Just like if, the code inside the while must also be properly indented. Let's create a variable called color and assign it the value red. Now we write a while loop that checks whether color is equal to red. Inside the loop, we print the color is red. Now let's understand what happens when we run the program. Python first checks the condition. Is color equal to red? Since color is red, the condition is true, so Python goes inside the loop and prints the color is red. After printing, Python reaches the end of the loop block and goes back to the top again. Now here's something very important. If we don't change the value of color inside the loop, the condition will always remain true and the loop will never stop. So inside the loop, after the print statement, we change the value of color to blue. Now let's see how the loop runs step by step. When color is equal to red, the condition becomes true and it prints the color is red. Now the value of color is changed to blue. So Python comes back to the top and checks the condition again. Is color equal to red? No, the condition is false, so Python stops the loop. So when we run the program, we see the message, the color is red, printed only once. Let's take another simple example. We create a variable called count and assign it the value 1. Now we write a while loop that checks whether count is less than or equal to 5. Inside the loop, we print the value of count. Now let's understand what happens when we run the program. Python first checks the condition. Is count less than or equal to 5? Since count is 1, the condition is true. So Python goes inside the loop and prints the value 1. After printing, Python reaches the end of the loop block and goes back to the top again. Now here's something very important. If we don't change the value of count inside the loop, the condition will always remain true and the loop will never stop. So inside the loop, after the print statement, we increase the value of count by 1. Now let's see how the loop runs step by step. When count is equal to 1, the condition becomes true and it prints 1. When the count is equal to 2, the condition becomes true and it prints 2. When the count is equal to 3, the condition becomes true and it prints 3. When the count is equal to 4, the condition becomes true and it prints 4. When the count is equal to 5, the condition becomes true and it prints 5. When the count is equal to 6, the condition becomes false and loop stops. So when we run the program, we see the numbers from 1 to 5 printed on the screen. Let's slow this down and think like Python. Check the condition. If true, then execute the block. Go back and check the condition again. Repeat until the condition becomes false. This cycle continues again and again. One of the most common mistakes beginners make with while loops is forgetting to update the variable used in the condition. If you forget to increase or decrease the value, the condition will never become false and the loop will never stop. This is called an infinite loop. An infinite loop is a loop that never stops running. This happens when the condition of the loop never becomes false. So Python keeps repeating the same block of code again and again without stopping. Let's take a simple example. We create a variable called count and assign it the value 1. Now we write a while loop that checks whether count is less than or equal to 5. Inside the loop, we print the value of count. Now think carefully. When Python checks the condition the first time, count is 1, which is less than or equal to 5, so Python prints the value. Now it comes back to the top and checks the condition again. The value of count is still 1, so the condition is still true, and this keeps happening again and again. So when we run the program, it never stops printing the same value. That's an infinite loop. Infinite loops are dangerous because they can freeze your program, they can consume a lot of CPU, and sometimes your system may stop responding. That's why understanding loop control is very important. To fix an infinite loop, we need to make sure that the condition eventually becomes false. This usually means increasing a value, decreasing a value, or changing a condition inside the loop. Once the condition becomes false, the loop automatically stops. Now, sometimes we intentionally want to stop a loop based on a condition inside the loop. For that, Python gives us the break keyword. The break statement is used to immediately stop the loop even if the condition is still true. So let's take an example. We create a variable count and start a while loop. Inside the loop, we print the value of count. Now we add an if condition. If count is equal to 3, we use the break statement. Now let's understand what happens. Python starts the loop and prints 1, 2, and 3. As soon as the count becomes 3, the break statement is executed and Python exits the loop immediately. The loop stops right there. The break statement is useful when you want to stop a loop based on some condition. You don't want to wait for the loop condition to become false, or you want more control over loop execution. All right, now let's talk about the for loop in Python. At first glance, the for loop might look a little confusing, but once you understand how it works, it actually becomes easier than the while loop in many cases. A for loop is used to iterate over a sequence of values. A sequence can be a list, a tuple, a string, or a range of numbers. So instead of manually changing a variable like we did in a while loop, the for loop automatically picks the next value for us. Let's start with a very simple example. Suppose we have a list of fruits. Now we want to print each fruit one by one. Instead of writing multiple print statements, we use a for loop. We write for fruit in fruits. Now let's understand what Python is doing here. Python takes the first element from the list and stores it in the variable fruit. Then it executes the code inside the loop. After that, Python moves to the next element, again stores it in fruit, and runs the loop body again. This continues until there are no more elements left in the list. Once all elements are processed, the loop stops automatically. Now, one important thing to understand is the loop variable. In the example, fruit is just a variable name. You can name it anything you want. Its job is to temporarily store each value from the sequence during every iteration. A for loop can also be used with strings. If we loop through a string, Python will pick one character at a time. So if we use a for loop on the word Python, Python will loop through each character of the string. The for loop is extremely useful when you know how many times something should repeat. You want to work with each item in a sequence. You don't want to manually manage counters. All right, now let's understand the range function, which is most commonly used with the for loop. So what is range? The range function is used to generate a sequence of numbers. It does not store all numbers in memory at once. Instead, it generates numbers one by one as the loop needs them. Let's start with the simplest example. We write a for loop using a range of 5. When we use a range of 5, Python generates numbers starting from 0 up to 4. So the loop runs with values 0, 1, 2, 3, and 4. Notice something important here. The number 5 is not included. This is because the range always stops one number before the given value. This might feel confusing at first, but this matches Python's indexing system. Just like lists and strings start at index 0, a range also starts from 0 by default. If we write a for loop with range 1, 6, Python will loop 5 times and print the values from 1 to 5. This is commonly used when you want to repeat something a fixed number of times, or you want to work with numbers directly. Now let's do something more interesting. Instead of just printing the numbers, let's multiply each number by 2 and print the result. Inside the loop, we perform the calculation and print the value. So now when we run the program, Python processes each element, applies the operation, and prints the output. This shows how loops help us process data efficiently. All right, now let's talk about loop control statements. Loop control statements allow us to change the normal flow of a loop. Instead of letting the loop run normally from start to end, we can stop it, skip certain parts, or leave it empty for now. Python provides us with 3 loop control statements: break, continue, and pass. Let's understand them one by one. We've already seen break with the while loop, but now let's see it with a for loop. Suppose we have a list of numbers. We start a for loop to print each number. Now, inside the loop, we add a condition. If the number is equal to 5, we use the break statement. Now let's understand what happens. Python starts looping and prints 1, 2, 3, and 4. As soon as the value becomes 5, the break statement is executed and Python immediately exits the loop. No further values are processed. So break completely stops the loop. We use break when we want to stop the loop based on a condition, or we don't need to process remaining elements, or we found what we were looking for. Now let's move on to the continue statement. The continue statement does not stop the loop. Instead, it skips the current iteration and moves directly to the next one. Let's take an example. We loop through numbers from 1 to 5. Inside the loop, we add a condition. If the number is equal to 3, we use continue. Now let's see what happens. Python prints 1 and 2. When the value becomes 3, Python hits the continue statement, so it skips the remaining code in the loop for that iteration and jumps back to the top of the loop. Then it continues with 4 and 5. So 3 is skipped, but the loop keeps running. We use continue when we want to skip specific values. We don't want to stop the loop entirely, or we want to ignore certain cases. Now let's talk about the pass statement. The pass statement does nothing. Yes, literally nothing. So why does it exist? In Python, we cannot leave a block empty. If Python expects a block of code and we don't want to write anything yet, we use pass. So when Python runs the program, it simply ignores the block and moves on. So let's quickly understand the difference. Break will stop the loop completely. Continue will skip the current iteration, and pass will do nothing, just acts as a placeholder. All right, now let's talk about nested loops. A nested loop simply means a loop inside another loop. So instead of having just one loop, we place one loop inside the body of another loop. Nested loops are used to work with rows and columns, compare each element with every other element, generate patterns, or work with multi-dimensional data. The structure looks like this. The outer loop runs first. For each iteration of the outer loop, the inner loop runs completely. So if the outer loop runs 3 times and the inner loop runs 4 times, then the inner loop runs 12 times in total. Let's take a simple example. We write a for loop that runs from 1 to 3. Inside that loop, we write another for loop that runs from 1 to 2. Now let's understand what happens when we run the program. When the outer value becomes 1, the inner loop will run for 2 times. When the outer value becomes 2, again, the inner loop runs for 2 times. And that last, when the outer value becomes 3, inner loop again runs for 2 times. So the inner loop runs completely for each iteration of the outer loop. One of the most common uses of nested loops is pattern printing. For example, if we want to print a square pattern using stars, we use an outer loop for rows and an inner loop for columns. The outer loop controls how many rows we print. The inner loop controls how many stars we print in each row. So when we run the program, we see the pattern printed line by line. Nested loops can become slow if used carelessly, so always make sure the loop conditions are correct, the loops are actually needed, and you understand how many times the code will run. So now let's move on to one of the most important concepts in Python, and that is functions. But before we jump into writing any function, let's just slow down for a second and understand why we even need functions in the first place. Up until now, whatever we've done, we've been writing code line by line. And honestly, for small programs, that works completely fine. But the moment your program starts getting bigger, one problem slowly starts showing up: code repetition. Let me show you what I mean. Let's say I want to calculate the sum of 2 numbers. So I write something like, take 2 numbers, add them, and print the result. Simple enough. Now imagine I need to do this again somewhere else in the same program. So again, I write, take 2 numbers, add them, and print the result. And then again and again. Now think about this. What if your program has 10 places, 50 places, or even 100 places where you're doing the exact same thing? Now, suddenly, your code becomes very long, very repetitive, and honestly, kind of messy. And here's the bigger problem. Let's say later you want to change something. Maybe instead of just printing the sum, you want to do something extra. Now you have to go to every single place and update the same logic again and again. And this is exactly where things start going wrong. Mistakes increase, things break, and debugging becomes painful. So instead of doing all this, Python gives us a much better way to handle it, and that is functions. Now think of a function like this. Instead of writing the same code again and again, we take that piece of code, write it once, give it a name, and then just reuse it whenever we want. So rather than repeating the logic, we just call it. You can think of it like a small machine. You give it some input, it does some work internally, and then gives you an output. And the best part? Every time you need that work done, you don't rebuild the machine, you just use it. That's exactly what a function does. So because of this, functions help us reduce repetition, keep our code clean and organized, and make our programs much easier to understand. And not just that, they also help us break a big problem into smaller, manageable pieces. And when your code is divided like this, debugging also becomes much easier, because you know exactly which part is responsible for what. And that's why functions are used everywhere in Python, whether you're writing a small script or building a large application. Alright, now that we understand why functions are needed, let's actually see how to create one in Python. So when we say defining a function, we're basically doing 3 things: telling Python that a function exists, giving it a name, and telling it what code it should run. Now let's actually write one. So I'll write def. This is a keyword in Python that tells Python, okay, I'm about to define a function. Now, after def, I need to give my function a name. Let's call it greet. And after the name, we always add parentheses. Then, at the end, I'll add a colon. So this line basically tells Python we are defining a function named greet. Now, whatever code I want this function to run, I have to write it below this line. But here's something very important to understand. The code must be indented. So now our function looks like this. We defined greet, and inside it, we are printing a message. Now here's something very important to understand. At this point, we have only defined the function. We have not executed it yet. So if I run this program right now, nothing will happen. And this is where beginners usually get confused. They think, I wrote the print statement, why is nothing showing? Because Python is just reading the function and storing it, not running it. So now let's actually call the function. To call a function, we simply write its name followed by parentheses. Now when I run the program, you'll see the output, hello, welcome. Now let's understand what just happened behind the scenes. First, Python reads the function block and then it understands, okay, there's a function named greet, so it stores it in memory. Then Python moves forward, and when it sees the function call, it immediately jumps to the function definition, runs the code inside it, and then comes back. And this is why just defining a function does nothing until you actually call it. Now here's where things get interesting. Let's say I call this function multiple times, so I'll just copy this function call 3 times. Now when I run the program, the same message gets printed 3 times. And notice something. We didn't rewrite the print statement 3 times, we just reused the function. And this is exactly what we mean by reusability. Write once, use it again and again. Now, one last important thing before we move ahead: indentation. Just like we saw in loops and conditionals, indentation matters a lot in Python. If I remove the indentation and write the print statement like this, Python will immediately throw an error because Python won't understand which code belongs to the function. So indentation is what tells Python this block of code is part of the function. Alright, now till this point, our function was doing the same thing every single time. No matter how many times we called it, the output never changed. But in real programs, we usually don't want fixed behavior like that. We want our functions to work with different data every time. So now, let's take the next step and understand how to pass data into a function. And for that, we need to understand 2 very important terms: parameters and arguments. Let's go back to our greet function. Right now, it looks something like this. It just prints a fixed message like, hello, welcome. Now think about this. What if I want to greet different people? Now, one way would be to create separate functions for each person, but that already sounds messy, right? We don't want to create a new function for every person, so instead, we make our function dynamic. So here's what I'll do. I'll go to the function definition, and inside the parentheses, I'll write a variable. Let's call it name. Now, what I'm doing here is very important. I'm telling Python, this function is expecting some value, and I'll store it inside name. This name is what we call a parameter. Think of it like an empty box waiting to receive a value. Now inside the function, I'll use this name, so I'll write print hello name. Now the function is no longer fixed. It can greet any person depending on what value we give it. Now let's actually call the function. So this time in the function call, I'll pass the name Mike. Now let's understand what's happening here. Mike is the actual value we are passing. This value is called an argument. So name is the parameter inside the function definition, and Mike is the argument that we passed while calling the function. Now when I run this, Python does this step by step. It takes Mike, assigns it to name, goes inside the function, and runs the print statement. So the output becomes hello Mike. Now the best part, we can reuse the same function with different values. So I'll write greet Bob and greet John. Now when I run this, you'll see hello Mike, hello Bob, and hello John as output.
And notice something, we didn't change the function, we just changed the input. And this is what makes functions flexible and powerful. Now let's take this one step further. A function can also take multiple parameters. Let's build something slightly more practical. Let's say we want to create a function that calculates the total bill of items. So I'll define a function called total bill. Now here, price is one parameter and tax is another parameter. Now inside the function, I'll calculate the total, so I'll write total equals price plus tax, and then I'll print the total bill. Now let's call this function, and this time we pass 118 as the arguments. Now let's break this down. 100 goes into price and 18 goes into tax. So inside the function, price is set to 100 and tax is set to 18. Then Python calculates the total and prints the total bill as output. Now here's something very important. The order matters. Let me show you. If I change the call to 18 and 100, now what happens? 18 goes into price and 100 goes into tax. Now the meaning of the values has changed. Even though the numbers are the same, the role they play is different. And in real programs, this can lead to wrong results if you're not careful. So always remember, parameter is variable in function definition. Argument is the actual value passed during function call, and the order of arguments must match the parameters. So now your functions are no longer fixed. They can take input, work with different data, and give different outputs. Alright, now up to this point, our functions were mostly printing values, which is fine. We could see the output on the screen. But now we're going to take things to the next level, and this is where functions become actually powerful. So now let's talk about the return keyword. Till now, inside our functions, we were doing something like this. We were writing print function to display the result. But here's the problem. Printing a value and returning a value are not the same thing. Let me show you why. So I'll quickly write a function that will going to add two numbers and then print it. So now if I call the add function and run the program, then you can see we're getting the sum of two numbers as the output. But now let's say I want to use this result somewhere else. Maybe I want to multiply it by 2. So this time I store the function call in a variable called result, and then I simply print the multiplication of result with 2. So now what do you think will happen? You might expect 16 as the output, but instead you'll get an error or unexpected behavior. Why? Because this function is only printing the value, not giving it back to us. So result is actually storing nothing useful, and this is exactly where return comes in. So let's modify the function. Instead of printing, I'll write return a plus b. Now what I'm doing here is very important. I'm telling Python, take this value and send it back to wherever the function was called. Now let's call it again and run the program. So now you'll see the 16 as the output. So what happens now? Python goes inside the function, calculates a plus b, which is 8, hits the return statement, and sends 8 back. And now result actually stores the value 8, and we multiply the result with 2, we get the 16 as the output. So this is the key difference. Print just shows the value, and return gives the value back so we can reuse it. Now there's one more important thing about return. The moment Python executes a return statement, the function stops immediately. Let me show you. Let's say we are creating a function called check that simply prints start, then return done, and then finally prints end. So now if I call check function and print it, what do you think will happen? The output we get is the start and done, but end will never print, because as soon as Python sees return done, it exits the function right there. Now let's talk about something interesting. A function can return multiple values. Let's say we are building something like a small student result system. We want a function that calculates total marks. So we're defining a function called result summary that takes maths, science, and English marks as parameters. And then we calculate the total marks obtained and the total percentage, and finally return the total marks and the percentage. So now notice I'm returning two values. So now I can call the result summary function, and this time I can store the result in a variable called total and percent. So what Python does is it packs the returned values into a tuple and then unpacks them into total and percent. So when we print the total and percent, we get both the total marks and the percentage as the output. So this is super useful when you want to return multiple results from a single function. Now, one last important thing. What if a function doesn't return at all? Let's test it. Let's get back to our greet function that simply prints hello. So now when I call the greet function and store it in a variable called result and then print the result. So now when we run the program, we first get the hello and then we get the none as the output. So why none? Because Python automatically returns none when there's no return statement. So this is Python's way of saying this function didn't return anything. So always keep this in mind. A function can print without returning, a function can return without printing, and if it doesn't return anything, Python returns none by default.
All right, now let's move to another very important concept, and that is variable scope. Till now, we've been creating variables, using them inside functions, outside functions, everything was working. But there's one important question we haven't really asked yet. Where exactly can a variable be used? And that's exactly what scope means. So in simple words, scope tells us where a variable is accessible in our program. And in Python, variables mainly fall into two categories, local variables and global variables. So first, let's talk about local variables. So first, I'll create a simple function called calculateDiscount, and inside it, we will create a variable called discount, and then we will print the discount inside the function. Now, if I call this function and run the program, then you can see we get the discount inside function 20 as the output. Everything works fine. Now let's try something interesting. After calling the function, I'll try to print the discount outside the function. So now if I run this, Python will throw an error. Why?
Because this discount variable is a local variable, which means it exists only inside the function and cannot be accessed outside. So once the function finishes execution, that variable is basically gone. So you can think of it like this. The function creates its own little world, and variables inside it live only in that world. And this is actually very useful, because it avoids name conflicts, keeps things clean, and makes functions independent. For example, two different functions can both have a variable named x, and they won't affect each other at all. Now let's talk about global variables. So what I'm going to do is, instead of creating a variable inside a function, this time I'll create a variable outside. Let's say we are building something like a small billing system. So first, I'll create a variable called tax rate. Now what I'm doing here is I'm setting a fixed tax rate that I might want to use in multiple places in my program. Since this variable is outside any function, this becomes a global variable. Now let's create a function that uses this. So I'm thinking, let's create a function called calculatePrice. This function will take a parameter called price. Now inside the function, I want to calculate the final price after adding tax. So what I'll do is I'll take the given price and add the tax rate to it. Notice what just happened. Even though the tax rate is not defined inside the function, I'm still able to use it. Now let's call this function. So what's happening here is price becomes 100, tax rate is 18 from outside, so final value becomes 118. And when I run this, you'll see final price 118 as output. So this shows something important. A global variable can be accessed inside a function without any problem. Now let's move to a slightly tricky situation. What if I tried to modify a global variable inside a function? Let's try it practically. So I'll create a variable called count and assign the value 0 to it. Now I'll create a function called updateCount, and inside this function, I'm thinking I want to increase the count. So I'll write count is equal to 10, and then simply print the count inside the function. Now let's call the function, and after that, I'm also going to print the value of count outside the function. Now, before running this, just think, what should happen? You might expect that count becomes 10 everywhere, but when we run the program, we get the value of count inside the function as 10, and outside the function, it's still 0. That means the original global variable was not changed. What Python actually did is, the moment I wrote count is equal to 10 inside the function, Python created a new local variable called count. So now we have one count inside the function, another count outside. Both are completely separate. Now, if we really want to modify the global variable, we have to explicitly tell Python. So I'll go back inside the function and write global count just above the count variable, and this time let's increase the value of count by 1. Now let's run this again. Now you'll see, inside the function, the value of count is 1, and also outside the function, the value of count has also changed to 1. So now it has actually updated the global variable, because we told Python, don't create a new local variable, use the global one. But now here's a very important thing. Even though this works, in most real programs, we try to avoid using global variables like this, because it can make the code harder to debug and harder to understand.
All right. Till now, whenever we were calling functions, we were passing arguments in a fixed way, like first value goes to first parameter, second value goes to second parameter. Simple. But Python actually gives us more flexibility when working with arguments. So now let's explore two very useful concepts, default arguments and keyword arguments. Let's start with default arguments. Let's build a small example. I'm thinking, let's create a function that sends a greeting message to a user. So we'll create a function called greetUser. This function will take two parameters, name and message. Now inside the function, I want to print a proper greeting. So I'll write print message and name. Now if I call this function and pass Mike and good morning as the arguments, so on running the program, you can see it works perfectly. But here's the thing. In most cases, the message is going to be the same, right? Like good morning, hello, something common. So every time writing it again and again feels unnecessary. So what I'll do now is I'll give a default value to the message. I'll go back to the function definition and set the message to good morning. Now what I'm doing here is very important. I'm telling Python, if no message is provided, just use good morning by default.
Now let's call the function again, but this time I'll only pass the name. Now what happens? Name becomes Mike and the message is not provided. So Python uses good morning. So we get good morning Mike as the output. Now let's say I want a custom message. So this time I'll write greet user and pass John as the name and the welcome as the message. Now Python will ignore the default value and use the one we provided. So we get welcome John as the output. So this is how default arguments work. They act like a fallback value when nothing is passed. Now, there's one important rule here. Default arguments must always come after normal parameters. So this is correct. But if I try to do something like this, Python will throw an error because it gets confused about which value goes where. Now, let's move to the next concept, keyword arguments. Till now, whenever we were calling functions, we were passing values based on position, like this. Here, Mike is set to name and hello is set to message. But what if we want more clarity? Or what if we forget the order? So instead of relying on position, we can pass arguments using parameter names. Let me show you. I'll call the same function, but this time we write name equal to Mike and message set to hello. Now what I'm doing here is I'm explicitly telling Python, this value goes to name, this value goes to message. Now here's the interesting part. I can even change the order. I can first write the message and then the name, and it will still work perfectly because Python is matching values based on names, not position. This makes the code much more readable, easier to understand, and less error-prone. Now let's try combining both. We will again call the function, and this time we pass Bob as a positional argument and message set to good evening. So here, Bob goes to name, which is positional argument, and message is passed using keyword. This works perfectly fine. But there's one rule you must follow. Positional arguments must come before keyword arguments. So this is valid, but this is invalid. Python will throw an error in this case, because once you start using keyword arguments, you can't go back to positional. So to quickly wrap this up, default arguments provide fallback values, keyword arguments allow passing values by name, and maintaining the order rules very important to avoid errors.
All right, now let's talk about something really interesting. Till now, what we've been doing is writing functions and calling them directly. But in Python, a function can also call another function. So let's create a small program where first we calculate something and then we display it nicely. So first, I'll create a function whose job is just to add two numbers. So I'll create a function called addNumbers that will take two numbers as a parameter, and then will simply return the sum of both the numbers. So this function's only job is to take two numbers and return the sum. Now I'll create another function. This function will be responsible for displaying the result nicely. So I will create a function called showResult. Now inside this function, I'll call the first function. So I will write result equal, and then I'll call the addNumbers function and pass 5 and 3 as the arguments. So now what I'm doing here is that I'm calling the addNumbers function and then store the returned value in result. And then I'll simply print the result. So now let's call the showResult function and run the program. So now let's understand what's happening behind the scenes. When Python sees the showResult function, it goes inside showResult, then it sees the addNumbers function, so it pauses the showResult for a moment, jumps to addNumbers, calculates 5 plus 3, and returns 8. And then it comes back to showResult function and stores 8 in result and prints it. So the flow is like outer function starts, inner function runs completely, and outer function continues. And this is super powerful, because now each function has a clear responsibility. One function is used for calculation, another to display result. Instead of writing everything in one big, messy block, we are breaking it into small, manageable pieces. Now, let's take this one step further. Till now, we were calling functions inside functions, but Python also allows us to define a function inside another function. So let's build that. I'll create a function called calculator. Now inside this function, I'll define another function. Let's call it add. Now this function will simply take two numbers and returns their sum. Now this is interesting. This add function is inside the calculator. Now still inside the calculator function, I will simply call the add function and store it in the result variable, and then finally print the result. Now let's call the outer calculator function. So on running the program, we get the result 15 as the output. Now here's something very important. Let's try calling the add function directly outside the calculator function. So on running the program, this time it will give an error. Why? Because this add function is a local function. It exists only inside the calculator. So think of it like this. A calculator has its own little world, and add lives inside that world. Outside, it doesn't exist. Now let's understand what's happening step by step. When Python reads the code, it sees calculator is defined, but the inner function add is not created yet. Only when we call the calculator function, then Python enters calculator, creates the add function, executes the code, and once it's done, everything inside disappears. Now here's the really powerful part. An inner function can access variables of the outer function. So let's modify our calculator function a bit. Now, inside the calculator function, I'll create a base value variable and assign it to 100. And now, in the add function, we will only going to pass one parameter and then add it with the base value. And then we will call the add function and pass 50 as the argument. So now here, inside add, I'm using base value. But notice I didn't pass it as a parameter. So when we run the program, it still works, because the inner function has access to the outer function's variables. So when I call the calculator function, output will be result 150. All right, now let's move to something very practical in Python, and that is file handling. Till now, all the programs we've written had one limitation. Whenever we ran our program, the program executed, the output appeared on the screen, and once the program ended, everything disappeared. So the data was temporary. Let's imagine a simple situation. Suppose you write the Python program that stores student marks, usernames, sales data, or notes. If this data only exists while the program is running, then the moment you close the program, all the data is gone. That's obviously not useful. We want the data to be saved permanently so that we can access it later, modify it later, or process it again. This is exactly what file handling is about. Many real programs use file handling. For example, a login system stores usernames and passwords in files. A notes application saves notes in files. A data analysis script reads data from CSV files. A game saves the player's progress in a file. So file handling is something you will use very often in real projects. So what can we do with files in Python? Using Python, we can create new files, open existing files, read data from files, write data into files, append new data, or delete files. And all of this is done using a very simple built-in function called open.
All right, now that we understand why file handling is important, the first thing we need to learn is how to open a file in Python. In Python, opening a file is done using a built-in function called open. This function allows us to connect our program to a file that exists on the computer. Once the file is opened, we can read data from it, write data into it, or update it. The basic syntax of opening a file looks like this. We write the open function, and inside the parentheses, we pass two things, the file name and the mode. The function then returns a file object, which we usually store in a variable so that we can work with the file later. So in simple words, the open function is like creating a connection between your Python program and the file on your computer. Let's imagine we have a file called data.txt in our folder. Now we want to open this file in Python. So we write a line of code where we call the open function and pass the file name. We store the result in a variable called file. What happens here is Python looks for the file, opens it, and returns a file object which we store in the variable. This variable now represents the file, and we can use it to perform different operations. If we print this variable and run the program, Python will show something like a file object in memory. This confirms that Python has successfully opened the file. It's important to understand that this variable is not the file content itself. Instead, it is a reference to the file which allows Python to interact with it. When opening a file, we also specify how we want to interact with the file. This is done using something called file modes. Some common file modes are R mode, which is short for read mode, W mode, which is short for write mode, and A mode, which is short for append mode. If we don't specify a mode, Python assumes read mode by default. So if we simply write open data.txt, Python opens the file in read mode. Modes tell Python what we intend to do with the file. For example, if we want to read data, we use read mode. If we want to write data, we use write mode.
If we want to add data without deleting the old content, we use append mode. Using the wrong mode can cause errors or even overwrite existing data, so it's very important to choose the correct mode. One important thing to remember is that if we try to open a file in read mode and the file does not exist, Python will throw an error. This is because Python expects the file to already exist when we are reading it. Later in the course, when we study error handling, we'll learn how to handle situations like this. The first and most common mode is read mode, represented by the letter R. This mode is used when we want to read data from a file. So when we open a file using read mode, Python allows us to view the contents of the file, but it does not allow us to modify it. Let's imagine we have a file called data.txt that contains some text. Now we open this file using read mode. When Python executes this line, it searches for the file, opens it, and gives us a file object. Now we can use that file object to read the contents of the file. One important thing to remember is that the file must already exist when we use read mode. If the file does not exist, Python will throw an error. This is because Python expects the file to already exist when we are reading it. Now let's move to write mode, represented by the letter W. This mode is used when we want to write data into a file. If the file does not exist, Python will automatically create a new file. But there is something very important you need to know about write mode. When we open a file using W mode, Python clears all the existing content in the file before writing new data, so the previous content gets erased. Suppose we open a file called notes.txt in write mode. Now, if the file already contains some text, Python will remove all of it. Then, when we write new data into the file, and only the new data will remain. So, write mode is useful when we want to completely replace the contents of a file. Now let's talk about append mode, represented by the letter A. Append mode is used when we want to add new data to the end of a file without deleting the existing content. So instead of replacing the file's content, Python simply adds new data after the existing text. Let's imagine we have a file that stores daily notes. If we open the file in append mode and write something new, Python will add the new text at the end of the file. The previous content remains unchanged. This makes append mode very useful for things like log files, data collection, and saving user activity. The last mode we'll talk about is exclusive creation mode, represented by the letter X. This mode is used to create a new file, but there is one important rule. If the file already exists, Python will throw an error. So X mode ensures that we do not accidentally overwrite an existing file. If we try to create a file using X mode and the file already exists, Python immediately stops the program and shows an error. This helps protect important files from being overwritten. Alright, now that we know how to open a file and choose the correct file mode, the next step is learning how to read data from the file. When we open a file in read mode, Python allows us to access the contents of that file. Python provides several built-in methods to read data from a file. The most commonly used ones are read method, read line method, read lines method. Now let's try to understand them one by one. The read method is used to read the entire content of a file. When we call this method, Python reads everything inside the file and returns it as a string. Suppose we have a file called data.txt, and it contains the following text. Now we open this file in read mode and try to read the content of the file using the read method. When we run the program, Python reads the entire content of the file and displays it. So the output will be exactly what is inside the file. Another useful feature of read is that we can tell Python to read only a certain number of characters. Inside the parentheses, we can pass a number. For example, if we pass 10, Python reads only the first 10 characters of the file. So instead of reading the whole file, Python reads only the specified number of characters. This can be useful when working with very large files. Now let's talk about the read lines method. This method reads only one line at a time from the file. So when we call read line method and run the program, Python reads the first line of the file and returns it. If we call read line again and run the program, Python reads the next line. So our file contains 3 lines of text. If we call read line once, Python returns the first line. If we call it again, Python returns the second line. And if we call it again, Python returns the third line. So each call reads the next line in the file. This method is useful when we want to process a file line by line. Now let's look at the read lines method. This method reads all the lines of the file, but instead of returning a single string, it returns a list of lines.
Each line of the file becomes an element in the list. If our file contains 3 lines of text and we use read lines, Python returns a list that contains all the lines as the elements. So it contains first line, second line, and third line. Now we can loop through this list and process each line separately. This method is very useful when we want to analyze or manipulate file data. When Python reads a file, it uses something called a file pointer. The file pointer keeps track of where Python is currently reading from. For example, if we read the file once using the read method, the pointer moves to the end of the file. If we try to read again, Python returns nothing because the pointer is already at the end. Now that we know how to read data from files, let's learn how to write data into files. Writing to a file means storing information permanently on your computer. Once the data is written, it stays inside the file even after the program stops running. To write data into a file, we usually open the file in write mode or append mode, and then use Python's built-in methods to write in the files. The 2 most commonly used methods for writing are write method and write lines method. Let's understand both of them. The write method is used to write a single string of text into a file. When we open a file in write mode and use the write method, Python places the text inside the file. Suppose we want to create a file called notes.txt and store a message inside it. We open the file in write mode and then use the write method to write some text. Now when we run the program, Python does the following. It checks whether the file exists. If the file does not exist, Python creates it. If the file already exists, Python removes the old content. Then Python writes the new text into the file. So after running the program, if we open the file, we will see the new text stored inside it. If we want to write multiple lines using the write method, we must include the new line character manually. The new line character tells Python to move to the next line. Without it, Python will write everything on a single line. One important thing to remember is that write lines does not automatically add new line characters. So if we want each line to appear on a new line in the file, we still need to include /n in each string. Otherwise, Python will write everything as one continuous line. All right, so far we've learned how to open a file, read data from a file, and write data into a file. But there is one more important step when working with files, and that is closing the file. Why do we need to close a file? When Python opens a file, it creates a connection between the program and that file. While this connection is open, the program can read or write data, and the operating system keeps the file reserved for the program. But once we are done working with the file, we should close that connection. Closing a file helps to free system resources, make sure all data is saved properly, and prevent accidental file corruption. Python provides a method called close to close a file. After we finish reading or writing data, we call the close method on the file object. So the flow usually looks like this. Open a file, perform operations, and close the file. Once the file is closed, Python releases the connection. If we try to perform any operation on a closed file, Python will show an error. Now, here's an important problem. Sometimes programs become larger and more complex. If an error occurs before the close statement runs, the file might remain open. This can lead to issues like memory leaks, locked files, and data not being written properly. So instead of depending on ourselves to always remember this, Python gives us a better and safer way, and that is using with keyword. So now let's write this step by step. We will write with open data.txt, r as file. Now let's try to understand this line properly. First, we wrote with. So what with is saying is, I want to open this file and safely handle it. Then inside it, we wrote open data.txt, r. So just like before, data.txt is the file name, and r is the mode. So we are basically saying, open this file in read mode. And what as file means is whatever file gets opened, we will refer to it using the name file. So instead of writing open again and again, we can just use this variable. Now after this line, you can see there is a colon, which means now we are entering a block. And inside this block, we can do whatever we want with the file. So I'll go inside and write content equal file.read and print the content. Now here's the best part. The moment this block ends, Python will automatically close the file.
We don't have to write file.close anymore. Now let's run this and you'll see everything works exactly the same as before, but now our code is safer and cleaner. And we can also use this for writing. So this time we can open the file using the append mode. And this time we'll use the write function to write something like, this line is written using with. So now as we run the program and open the file, you'll see the new line has been added. So from now on, whenever you open a file, try to use with, because it handles everything for you and you don't have to worry about forgetting close. All right, now let's move to another very important concept in Python programming, and that is modules. Before we understand what a module is, let's think about something. So far, we've been writing our programs inside a single Python file. As long as the program is small, this works fine. But imagine building a large program with hundreds of functions, thousands of lines of code, and different features like file handling, calculations, and user interaction. If everything is written in one file, the code becomes difficult to read, difficult to maintain, and difficult to reuse. This is exactly where modules come into the picture. A module in Python is simply a file that contains Python code. This code can include functions, variables, classes, or even executable code. So in simple words, a module is just a Python file that contains reusable code. Modules help us organize our code into separate files, each responsible for a specific task. For example, one module might handle math calculations, another module might handle file operations, another module might handle user input. This makes programs easier to understand, easier to maintain, and easier to reuse. One of the biggest advantages of modules is code reuse. Instead of writing the same functions again and again in different programs, we can write them once in a module and reuse them whenever we need them. This is a very common practice in professional software development. In Python, there are mainly two types of modules. Built-in modules, these come with Python itself, like the math module, random module, or datetime module. And then we have user-defined modules. These are modules that we create ourselves. We simply write Python code in a file and import it into another program. All right, now that we understand what modules are and why they exist, the next step is learning how to use them in our programs. In Python, we use modules through something called the import statement. The import statement allows us to bring the functionality of a module into our program. Once a module is imported, we can use its functions, its variables, and its classes. The simplest way to import a module is by using the import keyword followed by the module name. When Python executes the statement, it does the following. It looks for the module, then it loads the module into memory, then it makes the module available for use in the program. After that, we can access the functions inside the module using the dot operator. Let's look at a simple example using the math module. The math module contains many useful mathematical functions. First, we import the module, so we write import math. Now we can use one of its functions, such as the square root. To access the function, we write module name dot function name. So Python understands that we want to use the square root function from the math module. When we run the program, Python performs the calculation and returns the result. A Python program can import multiple modules if needed. For example, a program might use a math module for calculations, a random module for generating random numbers, or a datetime module for working with dates and times. Python allows us to import as many modules as required. When Python imports a module, it reads the module file, executes the code inside the module, and stores the module in memory. After that, the program can access the module's contents whenever needed. This process happens only once, even if the module is used multiple times in the program. All right, we learned how to import an entire module using the import statement. For example, when we imported the math module, we accessed its functions using the dot operator, like module name dot function name. While this works perfectly fine, sometimes we may not need the entire module. We might only need one or two functions from it. In such cases, Python allows us to import specific functions directly using from import. To import specific functions from a module, we use the following syntax. We start with the keyword from, then we write the module name, and after that we write import followed by the function name. This tells Python that we only want to bring a specific function into our program. Let's look at an example. Instead of importing the entire math module, we can import only the square root function. Now something interesting happens. Since we imported the function directly, we no longer need to write the module name with the dot operator. So instead of writing math.square-root, we can simply write square root function. Python already knows that this function came from the math module. We can also import multiple functions at the same time. To do this, we simply separate the function names using commas. So Python loads all the specified functions from the module, and we can use them directly in our program. This makes the code cleaner when we are using several functions from the same module. Python also allows importing everything from a module using the asterisk symbol. This tells Python to import all the functions, variables, and classes from the module. While this might look convenient, it is generally not recommended. Why? Because importing everything can clutter the namespace, cause name conflicts, and make the code harder to understand. That's why most programmers prefer to import only what they need. Alright, now let's talk about aliases when importing modules. Sometimes module names can be long or inconvenient to write repeatedly. For example, imagine a module with a long name that you need to use many times in your program. Writing the full module name again and again can make the code longer, harder to read, and slightly inconvenient. To solve this, Python allows us to give a short, temporary name to a module when importing it. This is called a module alias. To create an alias, Python provides the as keyword. The syntax looks like this. We import the module, and then we use the word as, followed by the new name we want to use. This new name becomes the alias of the module. From that point onward, we can use the alias instead of the full module name. Let's take the math module as an example. Instead of writing math every time, we can assign it a shorter alias like m. Now when we want to use a function from the module, we simply write the alias followed by the function name. So instead of writing math.square-root, we can write m.square-root. Python understands that m refers to the math module. Aliases are especially useful when module names are long, or the module is used many times in the program, or we want to keep the code shorter and cleaner. You will often see aliases used in many Python programs. For example, when working with data analysis libraries, programmers commonly use short aliases, like we import NumPy as NP or pandas as PD. Alright, so far we've been using modules that already exist in Python, like the math module. But one of the most powerful things in Python is we can create our own modules. A user-defined module is simply a Python file that contains code which we want to reuse in other programs. This code can include functions, variables, classes, or any Python statements. Let's imagine we are writing a program that performs several mathematical operations like addition, subtraction, or multiplication. Instead of writing these functions inside every program we create, we can place them inside a separate Python file. That file then becomes our module. Later, we can import that module into any program and use those functions whenever we need them. This helps us avoid repeating the same code again and again. To create a module, we simply create a Python file. For example, suppose we create a file called calculator.py. Inside this file, we define a few functions, like a function to add two numbers, a function to subtract two numbers, and one more for the multiplication of two numbers. Now, what I've done here is I've taken some useful logic and placed it inside a separate file. So this file, calculator.py, is now my user-defined module. Now let's actually use this module. So I'll create another file called main.py. This is where I want to use the functions from calculator.py. Now inside main.py, the first thing I'll do is import the module. So I'll write import calculator. Now what I'm telling Python is, go find the file named calculator and load it. Now let's actually use the functions. So I'll write result equals calculator.add and pass 5 and 3 as the argument. So in here, calculator is the module name and .add is the function inside that module. So I'm basically saying, go inside the calculator module and call the add function, and then I finally print the result. So on running the program, we get 8 as the output. Let's try another one. I'll write print calculator.subtract and pass 10 and 4 as the arguments. So on running the program, we get 6 as the output. Now let's quickly understand what happens behind the scenes when we write import calculator. Python does a few things.
It looks for calculator.py in the current folder, loads that file, executes all the code inside it, and makes all its functions available in the program. Now think about what we just did. Instead of rewriting add, subtract, and multiply in every program, we wrote them once in calculator.py, and now we can reuse them anywhere. So this helps us avoid repetition, organize code better, and build reusable components. And this is exactly how large Python projects are structured. Different files, different modules, all working together.
All right, now let's talk about something that happens in every real program: errors. Till now, all the programs we wrote worked perfectly because we controlled the input and the conditions. But in real life, things don't always go as planned. Users may enter unexpected values. Files may not exist. Calculations may fail. And when something like this happens, Python raises something called an exception. So what is an error? An error occurs when Python encounters something that it cannot execute properly. For example, dividing a number by 0, trying to convert text into a number, or opening a file that does not exist. When Python encounters such situations, it stops the program and shows an error message. This behavior is useful for debugging, but in real applications, we usually don't want the entire program to crash. Instead, we want the program to handle the situation gracefully. Imagine a program that asks the user to enter a number. Now, suppose the user enters text instead of a number. When Python tries to convert that text into an integer, it will throw an error. Without error handling, the program will immediately stop. But with proper error handling, we can show a message like invalid input, please enter a number, and then allow the program to continue. What is exception handling? Exception handling allows us to detect errors and manage them properly instead of letting the program crash. Python provides special tools for this, such as try, except, else, and finally. Using these tools, we can control what happens when an error occurs. All right, now that we understand why errors occur in programs, let's learn how Python allows us to handle those errors. Python provides two very important keywords for this: try and except. These two work together to detect and handle errors. The idea is actually very simple. We place the code that might cause an error inside a try block. Then we define an except block that tells Python what to do if an error occurs. So the program becomes more stable because instead of crashing, it can respond properly to the problem. The structure looks like this. First, we write the try keyword, and inside the try block, we place the risky code. Then we write the except keyword, and inside the except block, we write the code that should run if an error happens. Python first executes the code inside the try block. If everything runs successfully, Python skips the except block completely. But if an error occurs, Python immediately jumps to the except block and executes that code. Let's imagine a simple program where we're taking input from the user and dividing two numbers. So first I'm going to take two numbers as input from the users. Now I'll perform the division on these two numbers and then print the result. So now if I run the program and enter some random numbers, then you can see this works fine. Now, most of the time it will work as expected. But let's test something. If users enter the first number as 10 and the second number as 0, then in this case, Python crashes with an error called zero division error, because dividing by 0 is not allowed. So the problem is one small mistake from the user and the whole program stops. And in real-world applications, this is not acceptable. So now let's fix this. So now what I'm going to do is I'm going to take all the risky part of the code and put it inside a try block. And then I'll add an except block. And inside it, I'll simply print a message like cannot divide by 0. Now let's run this again. Now if everything is correct, Python runs the try block and skips the except block completely. But if an error happens, Python immediately jumps to the except block. So now if the user enters 0, instead of crashing, the program will print cannot divide by 0. Error handling is important because real programs often deal with user input, files, networks, and external data. Any of these can produce errors. Using try and except, we can prevent the program from crashing and provide meaningful feedback to the user.
So everything is working fine now. But the way we used except here was very general. It would catch any error that happens inside the try block. While this works, it's not always the best approach.
In many situations, we want to know exactly what kind of error occurred so that we can respond to it appropriately. This is where specific exceptions come in. Whenever Python encounters an error, it raises a specific exception type. For example, dividing by 0 raises zero division error. Converting invalid text to an integer raises value error. Trying to open a file that does not exist raises file not found error. Each error belongs to a specific category. By identifying these categories, we can handle different errors in different ways. Instead of writing a general except block, we can specify the type of exception we want to catch. So when Python encounters an error, it checks whether the error matches the specified exception type. If it matches, Python executes the code inside that except block. If it doesn't match, Python continues searching for another matching exception. Imagine a program that asks the user to enter a number. The program then converts the input into an integer using the int function, and finally, we print the result. So now, if the user enters a value like 10, then it works as expected. Python converts the string 10 into integer 10. Now, suppose the user enters text instead of a number. Python cannot convert text into an integer, so it raises a value error. So now, let's fix this using try and except. I'll take this risky line and put it inside a try block. Now I'll handle the specific error. So I'll write except value error and then print a message like invalid input. Please enter a valid number. So now let's run the program again, and if this time if we pass 10, then it works as expected. But now if we try to pass the string value, then instead of crashing the program, it prints invalid input. Please enter a valid number. So what we just did is we caught a specific error and handled it properly. Now let's make this a bit more realistic. I'm going to extend this program. Now I'll take two numbers as input from the users and divide them. So now there are two possible errors here. First is the user enters a text instead of numbers, then Python will raise the value error. And second, if the user enters 0, in that case, Python will raise the zero division error. So this time, instead of just one except block, I'll write two except blocks. In one, I'll accept the value error and print a message like, please enter valid numbers, and another accept the zero division error. And here we will print something like, cannot divide by 0. So now let's run the program and test different cases. So if users enter the first value as 10 and second value as 2, then we get 5.0 as the output as expected. But now let's say users enters the text instead of number. So this time Python catches the value error and prints, please enter valid numbers. And now let's users enter 0 as input. In that case, Python catches the zero division error and prints the message, cannot divide by 0. Now let's understand what Python is doing internally. When an error happens, Python checks the first except block. If it matches, then it executes it. And if not matches, then it moves to the next except block. So it goes top to bottom until it finds the correct match. Handling specific exceptions is considered better practice because it makes the program more predictable, avoids hiding unexpected errors, helps with debugging. If we catch every error using a general except, we might accidentally hide problems that we should actually fix. Alright, so far we've learned about try and except. We know that the try block contains code that might produce an error, and the except block handles that error if it occurs. But sometimes we want to run some code only when no error happens. This is exactly what the else block is used for. The else block runs only if the code inside the try block executes successfully. So the execution flow becomes Python executes the try block. If an error occurs, Python runs the except block. If no error occurs, Python skips the except and runs the else block. This allows us to separate the code that might fail from the code that should run after success. So I'm going to create a simple division program again, where users will provide two numbers as input, and then we perform the division operation. And again, since this is the risky code that may produce an error, so I'll keep this inside the try block. Then we will create two except blocks, one for handling a situation if users enters a text instead of numbers, and another to handle a situation if user enters 0 as input. Now comes the new part. I want to print the result only if everything worked fine. So instead of printing the result inside the try block, this time we will create an else block, and inside it we will print the result of division. So now if we run the program and enters 10, 2 as arguments, then this time try runs successfully.
Since no error occurs, Python skips the except blocks and runs the else block and print the result. Now, without the else block, we might write the result printing code inside the try block, but that can make the try block larger and harder to read. Using the else block helps keep things organized.
Alright, so far we've learned about 3 blocks used in exception handling: try, except, and else. Now let's talk about another block called finally. The finally block is special because it always runs, no matter what happens in the program. It does not matter whether an error occurs, no error occurs, or even if the exception is handled, Python will always execute the code inside the finally block. The finally block is mainly used for cleanup operations. Sometimes a program opens resources like files, database connections, and network connections. These resources should always be released properly even if an error occurs. The finally block ensures that this cleanup code always runs. Let's imagine a program that opens a file and reads its contents. So let's say we want to open the file data.txt and read the content of the file. So we will open the file in read mode and then read the contents of the file using the read method and print the content. Now we will place this code inside the try block because something might go wrong here, like file not found error. So if that's the case, then we will accept the file not found error and print the message like file not found. Now here's the important part. No matter what happens, I want to make sure the file is closed. So I will add a finally block now. And in here, I'll again going to write the try block. And inside it, I will write the file.close. And then write the except block that will do nothing but just pass. So now let's understand what's happening in here. First, let's assume the file exists. So Python enters the try block, reads the file, and prints the content. And then it will skip the except block and goes to finally block and close the file. But now let's say the file does not exist. In that case, Python enters the try block. Since file does not exist error will occur, then Python will jump to except block and print the file not found. And then it will again goes to finally block, but this time, since the file was not found, so instead of closing the file, it will simply run the except part and do nothing. So in both cases, finally runs. So finally is the last block to execute in the exception handling structure. Alright, so far we've been handling errors that Python raises automatically, like zero division error or value error. So Python was deciding when to raise an error. But what if we want to create our own error? Like we want to stop the program based on our own condition. And this is where the raise keyword comes in. Let's say we're creating a program where we take the user's age and convert it into the integer using the int function. Now technically this will work, but think about this. What if the user enter -5 as the input? That's not valid, right? Age can't be negative. But Python won't give any error here. It'll just accept the -5 like a normal number. So now we need to step in and handle this ourselves. So after taking input, I'll add a condition. I'll check if the age is less than 0. If it is, then we will raise the value error and print the message like age cannot be negative. Now what I'm doing here is very important. I'm manually telling Python if this condition is true, stop everything and raise an error. Now let's test it. I'll run the program and enter -10 as the input. So Python gives our value error with the message age cannot be negative. So instead of letting invalid data continue, we stop the program immediately. Now let's make this more user-friendly because right now it crashes. So I'll wrap this inside try except. So inside the try block, I'll add all of this code and print the age. Now I'll handle the error. I'll write except value error as e and then print the error, comma, e. Now let's again run the program, and this time first enter 25 as the input. Then in this case, we get your age is 25 as the output. And now if we again run the program, and this time if we enter some negative value, in that case we are getting error, age cannot be negative. So this time Python didn't raise the error itself. We raised it manually using raise and then handled it using except. So think of raise like this. If something is wrong according to my rules, I will create an error myself. Alright, so with that, we finally reached the end of this complete Python tutorial. We started from the absolute basics, slowly built our understanding step by step, and by now you've seen how all these concepts connect together to form real programs. At this point, the most important thing is not just watching, but actually practicing. Try writing small programs on your own, experiment with the concepts, break things, fix them. That's where real learning happens. And trust me, if you followed along till here, you've already built a very strong foundation in Python. Now from here, you can move towards things like projects, automation, data analysis, or even machine learning depending on what excites you. So yeah, that's it for this video. If you found this helpful, make sure to hit the like button, subscribe to the channel, and share it with someone who's learning Python. And I'll see you in the next one.